Mice pie. Mice never tasted so delicious.
Let X be the number of cars owned by a randomly selected household from the United States. Assume that the possible values of X are 0, 1, 2, 3, 4, and 5. The probability distribution of X is given below. And we want to find the expected number of cars owned by a household in the United States. How to find this expectation? Pause this video if you want to give it a try. Now, let's talk about how to find the expectation of a random variable. Here, let x be a discrete random variable with probability mass function given in the table below. Now, in this table, the first row are the possible values taken by the random variable x, and the second row gives the corresponding probability values. Their probability values has to be between 0 and 1, and their summation must be 1. The total probability is 1. Then the expected value of x, denoted by E in the parentheses x, or mu, is defined to be mu equals the expected value of x equals the summation over I xi times pi, which equals x1 p1 plus x2 p2 plus da 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 plus xr pr. This is the definition of the expected value of x. Now, the expectation of x can be found as follows. First, let's add another rule, x times p of x, to the probability mass function table. Here is the third row in blue. We have the product x p of x, x1 p1, x2 p2, xr pr. And then we just add all the terms in the third row and to get this expected value. Now, it's very easy. Now, let's solve this problem. All right, X is the number of cars owned by a randomly selected household from the United States, and the probability distribution is given below. We want to find the expected number of cars owned by a household in United States. Let's add another row, xp of x here. All right, so as you can see, that's 0 times 0.1, 1 times 0.2, 2 times 0.4, 3 times 0.15, 4 times 0.1, 5 times 0.05. This is our first step. Then to find the expected value of x, we simply add them all these products together. So we have this formula, mu equals their summation of their products, which equals this equation, which equals 2.10 if you use a calculator. So that is to say the expected number of cars owned by a household in the United States is 2.1. That's how we solve this problem. Now, a question, how can this number, the expected value of x, not be an integer? Now, here x is the number of vehicles, but the expected number is not an integer. Why is that? Now, here is the answer. The expected value is the theoretical average of a random variable. We can estimate it as the average of a large number of values of this random variable observed independently. Now that is to say, we select a household and see the number of cars this household has. And it may be 2 or 3, maybe from 0 to 5. And then we do select another household and got the number of vehicles they have, and got another one, and got another household, and so on. Now, the average can be a decimal point, a decimal number. Yes, even though for each household they must have an integer value, number of vehicles or cars, but their average can be decimal points. So that is the reason why this expected value can be a non-integer value. Okay, even the random variable can only take integer values. Their theoretical average can be a non-integer value. Now, before you leave, why don't you try the following problem? Let X be a random variable with the following probability distribution. Can you find the value of C? And can you find the expected value of X? Give it a try and leave a comment below. Thank you for watching. I will see you in the next episode. Bye bye.